So assess the use of fractional distillation to separate oxygen and nitrogen from air. Assess the use of filtration to separate sand from a mixture of sand and salt. Describe the property that is exploited to distill a mixture of ethanol and water. Explain how the process of centrifuging can be used to separate solids in a suspension. And what property is exploited in the separation funnel, and how does this facilitate the separation process? So assess the use of fractional distillation to separate oxygen and nitrogen from air. So essentially we're talking about, well, if we use this distillation process, how well does it work at separating nitrogen and oxygen? So fractional distillation can be used successfully to separate nitrogen and oxygen from air once the air has been liquefied. Nitrogen and oxygen have different boiling points. So oxygen has -183, whereas nitrogen is -196, which allows them to be boiled and condensed separately. So nitrogen will vaporize first, followed by oxygen. Assess the use of filtration to separate sand from a mixture of sand and salt. We've got sand and salt mixed together. How can we separate them? Well, this procedure won't work unless water was first added to dissolve the salt. Okay, so we won't be able to use this unless we add water to this mixture to dissolve the salt. If solid sand and solid salt were mixed and placed into a filter paper, neither would pass through the filter, so they won't separate. So it's just going to sit there in your filter and do nothing. Now, if we add water first, the mixture, and then stir the mixture, and so fully dissolve the salt, the filtration would be very good because it will be able to separate the sand from the salt and then just evaporate the water, and you'll have your sand and salt. So that will work. Sand is insoluble in water, so it would collect in the filter as residue, while the water and salt mixture would just flow straight through. Salt is soluble in water, so it would pass through the filter as the filtrate. To improve the accuracy of separation, the residue in the filter paper should be washed with lots of fresh water. Because some of the salt water can get stuck in the sand, we want to make sure we push all of that salt water through the filter so there's none left in the sand. So that's just to improve accuracy. The salt crystals would then be recrystallized by evaporating the water. So that's how we could use this filtration to separate sand and salt mixtures. Describe the property that is exploited to distill a mixture of ethanol and water. Well, differences in boiling point is exploited to separate ethanol and water. We want to be able to use the fact that they have different boiling points to separate them. So ethanol has a boiling point of around 78 degrees Celsius, while water boils at around 100 degrees Celsius. By heating the mixture to 78 degrees, the ethanol can be evaporated, leaving the water behind. Then the ethanol can be condensed, separating the two liquids. Explain how the process of centrifuging can be used to separate solids in a suspension, so solids that are in a sort of liquid. So solids in a suspension will naturally sink to the bottom due to the high density compared to water. So if they have a higher density compared to water, they'll sink to the bottom. Now, centrifuging accelerates this process by essentially making the acceleration bigger. So the forces acting on each particle are bigger because the acceleration is bigger. By rotating the mixture rapidly, the dense objects sink to the bottom while the larger objects sit on top. And that's how centrifuging works, exploiting density differences in different solids. And what property is exploited in the separation funnel? And how does this facilitate the separation process? Okay, so the two things that we're looking at here are insolubility and density differences. Denser substances sink to the bottom, while less dense substances float on top. Now, by opening the valve at the bottom, the dense liquid can be separated from the less dense liquid. So when you close the valve, you stop the less dense liquid flowing through the funnel. So you open the valve to let the dense liquid out, and then when you see that the less dense liquid is about to start going through the funnel, you close the valve and stop it, and then you've separated the two liquids. So that concludes today's lesson on separating mixtures. We've looked at lots and lots of different kinds of separation technique and why they work in terms of the physical properties. So hopefully you've learned something about these common separation techniques, and I look forward to seeing you at our next lesson.